Hi, Dr. Winters. This is Tisha Johnson. I am debriefing on Article 2, A Mathematical Cornucopia of Pumpkins by Glenn Gebhardt. This article's summary is about a 4-day investigation regarding pumpkins to basically have hands-on, minds-on exploration in mathematics and presents teachers with open-ended investigations to enhance mathematic instruction. The teacher will do a integration of mathematics and science on 4 different days, to where the learning goals on each day is different. The investigation can be used with grades 3 through 6, and the first day the lesson will be about posing interesting questions and making measurements on a pumpkin to find its mass. Lesson 2, which will be day 2, will be measuring volume and cubing the pumpkin to see how many seeds was actually in the pumpkin. Lesson 3, day 3, will be counting seeds and looking for relationships. Lesson 4, day 4, will be exploring interesting questions with scattered plots on graphs. Quote 1. At the heart of this investigation is the opportunity for students to gain confidence in asking their own questions and use math tools and analyze to answer these questions. These questions would become our interesting questions. When I talk about interesting questions, I'm talking about something we do not know and something that we can find out using our data. During our lesson 1 in the brainstorming phase, as the teacher, I asked my students to be in groups to brainstorm questions that would relate to the investigation. When students come up with questions regarding the investigation or something that we're trying to find out or do a study on anything, that builds their confidence in asking their own questions. So I turn it over to the students to ask their own questions regarding the volume, the mass, the height of this pumpkin. So one of the generated questions could be, in suggestion, measuring the pumpkin's volume. Okay, the question could be, how much space does the pumpkin take up? So the students could generate that question. How much space can a pumpkin take up? And that would actually promote finding the volume of the pumpkin. Quote 2. For investigations in mathematics and science to engage students, they must be fun. My reflection on quote 2 is that any hands-on activity that a teacher promotes through an integration dealing with more than one subject, it has to be fun. The students have to have buy-in on it, so you have to be excited. You have to be willing to go the extra mile to get the students engaged with great hooks and a great investigation to where they come out with real world experience to where they're going to be using some of this investigation, problem solving, critical thinking um, time that they're learning in the real world. And learning is better when it's fun. The students are more engaged, and when you're having fun, you learn more. Quote 1. At the heart of this investigation is the opportunity for students to gain confidence in asking their own questions and use math tools and analyze to answer these questions. Reflection on quote 3 is comparing elementary school students to real scientists and real mathematicians. When elementary school students is going through a hands-on investigation or activity that requires more than 1 or 2 days, they are actually in the real world role of scientists. They're probing questions, they're problem solving, and they're using their critical thinking skills, and they're collecting data. They're recording their data on spreadsheets and investigating different things about an object. In this article, it's pumpkins. So I love how you can use elementary school student activity with science and math, and basically it's exactly what scientists do and mathematicians do in the real world. They're actually putting their feet into a real world job and having practice and learning how those occupations in the real world do their jobs and what it takes to do their jobs.